Okay, I want to continue with this idea. So I've got several, iterations here. Hopefully by the end you'll really get it. So so I'm going to draw S sub 6. So S sub 6 is take 1, take away 1/2, add 1/3, right? So this would be S sub 3. So I'm just going to keep going. So I'm going to take away 1/4, add 1/5, take away 1/6. So right here would be where I would call S sub 6, right? So I would keep adding and subtracting, right? Adding and the next one, so the next thing I could add on would be here. But I know right in here would be the sum, right? If this is S sub 6, the next thing I would add on would be the 1/7, and that would be this distance here. So since the sum is right in here, farthest away, the error would be 1/7. That would be the farthest away I could be from the real sum, which is somewhere in between. So I don't know if I need to keep going through all of these. So, if I use S sub 7, so here's S sub 7, the sum right here, right, S sub 7, then the next thing I would do would be subtract off 1/8, which would be this direction. The real sum would be somewhere in here. So the farthest away, right, I could say that the error would be less than the next term. So the next term gives me the error, or as far away from the sum as I can be. This only comes from it being alternating, terms decreasing and going to 0. So yeah, I think I kind of went overboard on showing too many examples of this. Okay, so let's go through and do a problem. So what does it mean to approximate a problem to 3 decimal places? So that would mean the error would be less than 0.001. So that means that the first decimal place, 3 decimal places, are not affected. And so if you're asking if it's to be correct to the first 3 decimal places, that same thing. The first 3 decimal places are not affected if you add on the next term. All right, how many terms are necessary to approximate the sum of this series to 3 decimal places? So that's the same thing as saying that the error is less than 0.001. All right, so I would write out the terms of the series. And I wouldn't start to kind of figure out what the decimals are until about here, right? Because you've got to have 3 decimal places, and these aren't very small. So I get to this. This number here, 1/720, still affects the first 3 decimal places. So this is still needed. The next term here does not affect the first 3 decimal places. So this is not needed. So I don't need this term. I do need up to here. And so be careful. Many of these with factorials, they start at 0. So be careful when you're counting terms, right? So 1, 2, 3, 4, 5, 6, 7 terms are needed to approximate the sum to 7 decimal places. Okay, so how many terms are necessary to find the sum of the series for this to 6 decimal places? All right, so same one. So that just means I have to go out further. So 6 decimal places means I have to have 1, 2, 3, 4, 5, and a 1. Less than this, right? So less than this means 6 decimal place accuracy. So I just want to make sure you see what they mean. So if I use n equal 9, I get this. And you know that this on a calculator means move the decimal places over 6 places in this direction. So there'd be 5 zeros and then a number, right? So this still affects the 6th decimal place. So I still need that one. If I use this one, n equal 10 in here, 1/10 factorial, I get this, which means there's 6 zeros in this number. So this does not affect the first 6 decimal places. So I want to go from n equals 0 up through n equal 9, including 9. And so adding those numbers, that means there's 10 terms. All right, let's look at this one. So I want to approximate this sum to 3 decimal places. That's the same thing as saying this is not correct. Hold on.